Hello, dear students in grade 8. This is lecture 9 in mathematics, and the title of this lecture is The Midpoint Theorem. This lesson and the midpoint theorem is very important. Please watch the video well. Don't hesitate to ask me if you have any question. And as I said, this theorem is very important for next year in geometry for grade 9. So let me start. Objectives of this lesson. Before I start talking about the midpoint theorem, number one, we will identify and apply the properties of a trapezoid, which is a quadrilateral. Number two, recognize and use the midpoint theorem in a triangle and a trapezoid. Number three, apply the converse of the midpoint theorem in a triangle. The converse means the opposite of the midpoint theorem. Number four, identify and use the characteristics of an isosceles trapezoid. Before I start with the midpoint theorem, let us refresh memory of a theorem we studied before in mathematics in our lesson, which was about special parallelograms. If you still remember when we talked about the special parallelogram or the quadrilateral, which is the rectangle, we talked about a very important theorem called the median segment theorem. We should know that the median segment theorem is only applied in a right triangle, so I cannot apply it in any other triangle unless it is right. Also, we studied before the definition of the median segment theorem. What's a median segment theorem in a triangle? The median segment is a line from the vertex to the midpoint of the opposite side. So what will we be given to apply the median segment theorem? As given, you have triangle ABC right at A, and M is the midpoint of BC. You know that side BC in the right triangle is called the hypotenuse. So the median segment theorem is relative to the hypotenuse in the right triangle. So now I'm given also M is the midpoint of the hypotenuse BC. Now, what should I prove? I should prove that AM, for example, is equal to 3 centimeters, or I should calculate the length of the median segment AM. How can I calculate the length of the median segment AM? I say, since triangle ABC is right at A, and M is the midpoint of segment BC, then the line joining M with the opposite vertex, what do we call it? The midpoint with the opposite vertex, it's called a median segment. So AM is the median of side BC. So we say, using the median segment theorem, AM is equal to side BC over 2. This is the median segment theorem. So I have the length of BC, for example, 6 centimeters. So I say AM is equal to 6 over 2, then AM is equal to 3 centimeters. And since, as you know, M is the midpoint of segment BC, then AM will be equal to MB will be equal to MC. We have the converse of the median segment theorem. What do we mean by the converse? We will be given any triangle, and we should prove that this triangle is right. So the converse of the median segment theorem, we use it to prove that a triangle is right. As given, we have triangle ABC is any triangle, and M is the midpoint of segment BC, such that AM is equal to MB is equal to MC, and each one of them is equal to 3 centimeters. We should show that or prove that the triangle ABC is right at A. What do I say? I say, since M is the midpoint of segment BC and AM is equal to MB is equal to MC, then AM is equal to BC over 2. Using the converse of median segment theorem, triangle ABC becomes right at A. This is very important. Practice it, please. Now I'm going to talk about a new quadrilateral, which is called the trapezoid. It is a quadrilateral which has 4 sides, but only 2 of its sides are parallel. As you can see, quadrilateral ABCD. AB side is parallel to side DC. AD and BC are called legs of the trapezoid. These are the non-parallel sides. AC and BD are the diagonals. AB is the small base and DC is the big base, or CD is the big base. Special trapezoids. We have the right trapezoid, which has 2 equal sides, 2 of its angles are right. As you can see, the parallel sides are perpendicular to one of the legs. So it has 2 right angles. The 2 parallel sides are perpendicular to the same side. And this angle is equal to 90 degrees. This angle is equal to 90 degrees. The isosceles trapezoid, similar to the isosceles triangle, it has 2 equal sides. But which sides are equal? The non-parallel sides, or the legs, are equal. So the legs are equal. Angles adjacent to the bases are equal. For the small base, we have 2 angles, so these 2 angles are equal. For the big base, we have 2 angles, so these 2 angles are equal. The bases have the same perpendicular bisector. So if I draw the perpendicular bisector of the first side, it will also be the perpendicular bisector of the second base. Now let me start talking about the midpoint theorem in a triangle. What is the midpoint theorem in a triangle? It is in any triangle. So we use it in any triangle, right? Isosceles, equilateral, scalene, whatever. The segment joining the midpoints of 2 sides is parallel to the third side and equals its half. For example, I have a triangle ABC. M is the midpoint of segment AB and N is the midpoint of segment AC by given. Then the line joining the 2 midpoints, which is MN, will be parallel to the third side. So MN will be parallel to BC. Not only this, MN will be equal to BC over 2. So this is the midpoint theorem. The converse of the midpoint theorem, we use it to prove parallel lines. So if I wanted to prove, for example, in triangle EFG, that side KM is parallel to side FG, I use the converse of the median segment theorem, of the midpoint theorem. So the midpoint theorem, its converse is, for example, if I have a triangle EFG, and in it, I have 2 parallel sides, 2 parallel lines, and one of them is passing through the midpoint of any of the sides. So in triangle EFG, we are given that K is the midpoint of EF. So by given, I have K, the midpoint of EF. And by given, I have KM is parallel to FG. So since K is the midpoint of EF and KM is parallel to FG, then of course KM will be passing through the midpoint of EG, then M will be the midpoint of EG. So why do we use the converse of the midpoint theorem? We use it to prove that a point is the midpoint of any of the sides of a triangle. The midpoint theorem in a trapezoid. We have a trapezoid ABCD. M is the midpoint of AD. N is the midpoint of BC. So we have the midpoints of the non-parallel sides. So the line joining MN is parallel to the 2 bases. It's parallel to AB and is parallel to DC. Now, MN is equal to AB plus CD over 2, and IJ, what are IJ? The intersection of MN with the diagonals is IJ. IJ equals CD minus AB over 2. And these are exercises for you to practice using the midpoint theorem. So please read these exercises well, and you have the figure in front of you. Practice well these exercises before start solving the exercises in our book. As I said, watch the video well. This is a very easy lesson. the midpoint theorem and the median segment theorem are very important. Please differentiate between them. And if you have any question, please contact me. Thank you.